Today's notes are on solving systems of equations using matrices. Now, we've already talked about how to solve systems of equations. We've already gone through these three rules that we may interchange two rows or two different equations, multiply a row or an equation by a non-zero number, or add a multiple of one equation to another. Now, this method today is going to seem more complicated, more complex to start. But as we get into bigger and bigger systems of equations, today's method is going to be the preferred method that we're going to use most often. Okay, now this is the guy that came up with this method. His name is Carl Gauss, lived back in the 1800s in Germany. Actually did a lot in mathematics, but this method is sometimes called the Gaussian method, named after the person who came up with it, Carl Gauss. Okay, so let's go through this system of equations. We want to solve this system. Now, I know there's other ways you can solve this. We can combine these equations, we could graph both of these, but I want to introduce this new method to solve this system of equations using matrices. Here's what we want to do for this. We want to set up a matrix that is going to have these coefficients of x and y and this answer in the top row. So 1, 3, and 19 in the top row, and then these coefficients and this answer in the second row, -2, 5, and 39. And what we want to do, we want to somehow combine rows, multiply rows by something to get this goal over here. So here's our goal matrix. The goal matrix has 1, 0, and then some number on the top row, 0, 1, and then some number on the bottom row. If we can move rows around, multiply rows by something to come up with that goal, these two numbers here will be our solutions for x and y. And if you think about it, if we rewrote it as a system of equations, it would be 1x plus 0y equals this number, or 0x plus 1y equals this number. Okay, so probably the best way to go through this is to try to start in this upper left-hand corner and go around in this fashion. Okay, so start with that 1, then go counterclockwise around those four numbers there. Okay, I'm going to get this thing out of the way here so we can work with this. So the nice thing, the convenient thing about this particular system of equations is that there's already 1 in the top left corner, so we're good. So let's try to get a 0 in this bottom left corner. Here's how we can do that. If we multiply the top row by 2, and then add what we get to the bottom row, we're going to make a new row that has 0 in this spot. So I'm going to keep the top row as is, 1, 3, 19. I'm going to make a new bottom row, and I'm going to get that by multiplying the top row by 2, adding it to the second row here. So 1 times 2 is 2, plus -2 is 0. 3 times 2 is 6, plus 5 is 11. 19 times 2 is 38, plus 39 is 77. So we made a new bottom row by multiplying the top row by 2 and adding it to the old bottom row. Now, as you can see, we're halfway to our goal. We've got a 1 in this spot, 0 in this spot. Next thing we want to do is try to get a 1 in this spot here. Okay. To do that, here's what we can do. Let's divide that entire bottom row by 11. We know we can multiply a row by any number. That also implies that we can divide a row by any number. Okay, that's going to give us a new bottom row. So I'm going to keep the top row as is, 1, 3, 19. The new bottom row is going to be 0, 1, 7. Okay, beautiful. We are almost to our goal. We've got a 1 in this top left spot, 0 in the lower left, 1 in the bottom right. Now we need to get a 0 in this top right spot. So just like before, where we multiplied a row by something and added to give us a 0, let's do the same thing. Let's multiply the bottom row times -3. And then let's add that to the top to make a new top row. So the bottom row is going to stay as is, 0, 1, and 7. Our new bottom row, if I multiply what's on bottom by -3, add to the top, I get a new top row. 0 times negative 3 is 0, plus 1 is 1. 1 times negative 3 is negative 3, plus 3 is 0. 7 times negative 3 is negative 21, plus 19 is negative 2. Now this format here, this is what's called reduced row echelon form, and this is our goal. This is what we want. Here's what that tells us. It tells us that negative 2 is our solution for x, 7 is our solution for y. So there's our coordinates of our solution. Now I know there's easier methods to solve this particular system of equations. However, when we get systems that might have, let's say, 10 different variables, this method with matrices is going to be our easiest method by far. Okay, let's try a more complex one. Okay, here's our system of equations. And my first step, I'm just going to rewrite this system as a matrix. 1, 0, negative 3, and negative 5. 3, 1, negative 2, and negative 4. And then 2, 2, 1, and negative 2. Our goal in this case is to get all 1s across the diagonal, and then our solutions will appear in the far right-hand column. So here's our goal. This is what we want in the end. This is reduced row echelon form. Okay, now the convenient thing here is we already have a 1 in the upper left corner. If you ever don't and you can switch things around, that's a good thing to do to start. So we've got a 1 there. So let's multiply that top row by negative 3 and add it to the second row to give us a new second row. So we'll multiply top row by negative 3. We can add that to the second row to give us a new second row. So let me bring the top row down. 1, 0, negative 3, negative 5. Let's make a new second row. 1 times negative 3 is negative 3, plus 3 is 0. 0 times negative 3 is 0, plus 1. Negative 3 times negative 3 is 9, plus negative 2. And negative 5 times negative 3 is 15, plus negative 4. Now, let's do the same thing to get a 0 in that bottom row. So now I'm going to switch colors for this one. Let's multiply the top row by negative 2. Add that to the bottom row to give us a new bottom row. Okay, 1 times negative 2 is negative 2, plus 2 is 0. 0 times negative 2 is 0, plus 2. Negative 3 times negative 2 is 6, plus 1 is 7. And negative 5 times negative 2 is 10, plus negative 2 is 8. Okay, so we are partway to our goal. Okay, the next thing we want to do, notice we have a 1 in this spot, 0, we've got a 1 here. Let's try to get a 0 in this spot here. Okay, so let's multiply. Now we want to multiply this second row by something. Let's multiply the second row by negative 2 and add that to the bottom to give us a new third row. Okay, so top row I like, I'm going to keep. Second row I like, I'm going to keep. Let's get a new third row. So 0 times 0 is 0, plus 0, that stays as is. 1 times negative 2 is negative 2, plus 2 is 0. 7 times negative 2 is negative 14, plus 7. And 11 times negative 2 is negative 22, plus 8 is, what is that, negative 14. All right, beautiful. All right, thinking of going counterclockwise, here's our next step right here. Let's try to make this into a 1. And if we divide everything in that row by negative 7, this should take care of that. I'm going to bring all my work up here. Okay, so top row stays as is. I like the top row. Second row stays as is. We like that. Bottom row, if we divide everything by negative 7, gives us 0, 0, 1, and 2. Okay, this is good. This is looking good. So on the left side, we've got our 0s and 1s forming. Now we've got to keep working upward and counterclockwise to get some more 0s in these spots. Okay, so just like we started by multiplying the top row by something and adding down, let's now multiply the bottom row by something and add up. So our next step is to get a 0 in this spot. If we multiply the bottom row by -7 and add up, we'll get a new second row. Okay, so I'm going to keep the bottom row, 0, 0, 1, and 2. Multiply the bottom row by -7. We'll get 0. 0 plus 1 is 1. That gives us -7 plus 7 is 0. 2 times -7 is -14, plus 11 is -3. Beautiful. Now, let's do another multiplication. Let's try to get a 0 in this spot. If we multiply the bottom row by 3 and add, that'll give us a new top row. Okay, 0 plus 1 is 1. 0 plus 0 is 0. 1 times 3 is 3, plus -3 is 0. And 2 times 3 is 6, plus -5 is 1. Okay, check it out. We've achieved our goal. We've got 1s across the diagonal, 0s in these other spots. These numbers down the last column are our solutions. So now 1 is the solution for x, -3 is y, and 2 is the solution for z. Okay, so that is how to solve a system of equations using matrices. And I tell you what, it is more complex than our other methods of solving systems. However, once you get this down, this method is actually easier for more and more complex systems. So practice a few of these. They are challenging, they're tough, but once you get the hang of it, you'll do just fine.